Hello guys, welcome to Surveying Solutions, your number one channel where you get solutions to all your surveying problems. It's nice having you in class again today. How have you been? We are going to have quite an interesting one today. You know, when you are on site, maybe for traverse or whatever field operation, and you are trying to observe from a known point to, let's say, 3, 4, 5, 6, or as many unknown points, and you have been able to measure the distances and the bearings from where you are to those unknown points, you can easily get the coordinates of those unknown points. So let's say you are on station A, as you can see here. You know the coordinates of station A. That now identifies the point. So we have tried to, or let's say we also got the bearings and the distances here from that known points to 1, 2, 3, 4, right? Good. Now the task is for us to now locate those unknown points by using these bearings and distances, or let's say distances and bearings. We are going to use AutoCAD, and then we are also going to use our calculator. So now for us to get the distances and the bearings, for us to get the delta nothings and the delta hastings, which we are going to apply to the coordinates of A to now give us the coordinates of our unknown points, we are going to use the distance and the bearing. So if you have your calculator there, we use this Casio series, I think Casio FX991EX or so. So if you have your calculator, you can just go by saying shift rec, right? Good. Now it allows you to impute your distance and bearing. So our first distance is 128.395, right? Good. Then the bearing for that line is about 7 degrees, 9 minutes, and then 33 seconds. So if we have typed it right, the delta nothings we can see, or we should see on our calculator, is 127, right? 0.394. Sorry, that isn't point. Let's go back. This should be point, right? Good. Then for the delta easting, we should have something like 16.001, right? Good. So that's how you get the delta nothings and delta eastings from your distance and bearing. So now let's do that of 0.2. So the same approach, shift minus, which is actually rec. So our distance is 160.106, and then the bearing to that point was 32 degrees, 52 minutes, 25 seconds, right? Good. So we have 134.468. Then we have the delta easting to be 86.904, right? Good, 904. Ensure you confirm these values on your calculator. So for the purpose of time, you can use maybe your calculator to get that of 0.3 and 0.4, right? Good. So let's copy this out. Let's give some space, and then let me just do something like this. Then let's give it a space. Sorry, comma, right? Good. Then let me copy this as well. Just prefer doing it like this. Good. So we have what our easting, comma, nothing. So we can just copy that, and then we pick the polyline tool, then we paste it there, right? Good. So we have what our easting, comma, nothing. Then we hit enter. Now the point has been plotted. However, we don't know where it is. So just select any point, then zoom extent, right? Good. So let's now try to zoom to where that point is. So this exactly is where the point is, right? Good. The reason why we did it like this is for us to identify this point, because this is actually the point. If we pick the polyline tool again, and then we paste the point and we hit enter, you will find out that it's actually plotted here, right? Good. We now come back to our notepad. Remember, we wrote something like at distance, comma, bearing. What this means is that we are going to use this particular format to plot our distances and our bearing. So how do we do that? Good. So when the first point has been plotted, the idea behind using AutoCAD, or let's say the approach we are going to use, is for us to use what? The line tool. Now, the reason why we want to use the line tool is for us to be able to plot out those lines, like from our known points to those unknown points. Then we can now later join them, right? Good. So we just pick the line tool, right? Good. Then we specify the first point, which is actually where we are. Enter. That's somewhere around here, right? Good. Now, using that same line tool, let's now plot the distance and bearing that leads or that directs us towards to the first unknown point. So how do we do that? We come down here, we type what? At, and then what's the distance? We have about 128 point what? 395. So we have 395. Then we have less than, right? Good. Then we have a bearing of 7 degrees, 9 minutes, 33 seconds, right? Good. So we have 33 seconds. Then we hit enter. So the first line has been plotted. Are we together? So we just escape. We come back to our first point by using the line tool. Remember that the coordinate of that first point has been copied. So we still paste it and it takes us to the first point, right? Good. So from that first point, remember that all observations were made from that first point, right? Good. So from that first point, we now do what? We move to the second unknown point, right? Good. So we have a distance of so we still come by at 160 point what? Less than 32, 52, and I think 25, right? Good. So we have that. We hit enter. So you now see the second what do you call it? The second point has been identified. Escape. We still pick our what? Our line tool. We specify our origin. Paste it there. Enter. And then from our origin, we navigate to the third unknown point, right? Good. So we still have what? At what's the distance? We have 160.106. Is that 106? Then we have what? Less than, right? Good. We have 58 degrees, 35 minutes, right? Then 16 seconds. So that's something like this. Then we hit enter. So that's the third point identified. We escape, we pick our line tool again, then we still paste the coordinates that we have copied, enter. It takes us to our known point, which is the origin. Then we move to the fourth, or let's say the final unknown point that we have for today's video, right? So we have at what's our distance? We have 128, right? Good. 128.395. So we have 395. Then we have something like what's the bearing? 84 degrees, 18 minutes, and then we have 8 seconds, right? Good. So sorry, that's not minutes, this should be minutes, right? Then 8 seconds. So we have something like that. Then we hit enter. So you can see that from the origin, we can decide to just delete this line because we don't need it from the beginning. So you can see now that from our origin, we have been able to identify point A, point B, point C, and point D, right? Good. Using the distance and the bearing, because all observations were made from this known point, right? Good. So we have identified this as point A. We are saying this is 1, 2, 3, 4, depending on where you want to start from. So having located the points like this, you can decide to pick your polyline and join them together. So you have this point joined to this point. Maybe there's an order you followed. If you're coming from this direction to that direction or from any other direction, you can just try to join the points. Let's just come down here again. So we click on enter. So we have our polygon. So we can decide to erase all of these resection lines. So we have our polygon like this. So this is the enclosure, or let's say this is the parcel of land, or let's say this is the area that was surveyed. So with this, you know that yes, this is your known point, maybe the control point, and then these are the established points using what your distance and your bearing. So we have deleted those observed lines. Yeah, those observed lines, that's the distance and the bearing. The lines that we are established using the distance and the bearing, and we have what the coordinates of these points. So now let's come back to our notepad. For this first one, let's try to see if we can get the coordinates of point 1 before we try to call it a quit on today's video. So let's say we know the coordinates of point A, and then we have the delta northings and the delta eastings of the line from A to 1, which means we are going to add these delta northings and delta eastings to the easting and northern coordinates respectively of point A, right? Good. So let's do that and let's get the final answer. Good. So from our calculation, we have seen that this is the coordinates of point 1. So let's see if we are going to get the same coordinates as this from AutoCAD. So remember when we first plotted, I think this was the first point that we plotted, followed by this, and then get into this. I remember that should be the order. So now let's ID. So the command is what ID, right? Good. So let's ID this point so that we can see the coordinates. So we have something like this. Let's copy it out and then compare it to what we have on Notepad. Let's see if they are the same. Good. They are actually the same, right? Good. So we have what 860112. Sorry, this is supposed to be 112, not 113. This is 127, right? Good. I typed 128, so that's why we have 113 somewhere around. Yeah. So this is supposed to be 112. Good. So 860112 point what? 827. That's what we calculated, and what AutoCAD listed was the same value. Then for the northings, we have what 600,217.742. AutoCAD listed 600,217.742, right? Good. Remember ours was rounded off to 3 decimal places, whereas CAD rounded it off to what 4 decimal places. That's why you can see this extra 4. So in essence, what we are trying to say is that we have been able to identify the coordinates of those unknown points, which is 1 to 4. Please ensure you complete these other fields. Yeah, good. Ensure you do these calculations and then you get your values correctly, right? Good. So we have been able to identify the coordinates of 1 to 4 using AutoCAD, and then we have also shown you how to get the coordinates of 1, maybe using your calculator. So if you want to get the coordinates of subsequent points, as we have used ID because that's the command, you can just ID this other point. You can still use ID to ID this one, or you can just click on the polygon and then list by using the list command, which is what LI. So when you type list, you would see the coordinates what listed out, right? Good. So you see the first coordinate repeated because that's what forms the loop, right? Good. So you now see the coordinates of all of the points. We have 1, 2, 3, 4, 5. All of the 5 points listed out, so you can proceed with whatever you want to do with the coordinates. So this is how you use AutoCAD and then how you use your calculator to get the coordinates of unknown points from a known point, using the distances and the bearings of the respective lines that were maybe calculated or maybe measured or observed from site. So thanks for coming to class. We hope we've provided solution to this particular solving problem. We are going to see you on our next video. Until then, ensure you keep staying safe and have a very good time. Bye.